Alright, so we're given this differential equation right here, and we're told to solve for it using series methods. Now, we know that our final answer is going to have this form. So what that means is y is going to be equals to a sub n times x to the power of n, going all the way from 0 to infinity. Alright, so first thing we want to do is find the first and second derivatives of y, which a sub n is going to be a constant, so it's going to stay. You bring down the n and then multiply times x to the power of n minus 1. Now, this one's going to have to start at 1 instead of 0 because this n that was added, but it's still going to go to infinity. And it's the same process with the second derivative. A sub n is a constant. This n is also a constant. Then you bring down the n minus 1 and multiply times x to the power of n minus 2. It goes to infinity, and just like the last one, this one has to start 1 above. Alright, so now we have we have y and its first two derivatives. That means we can plug it in for the y and its first two derivatives that are in this differential equation. So it goes y, second derivative of y, plus I believe x times the first derivative of y, and minus 3 times y equals 0. Let me just make sure I got that right. Yeah. Alright, so let's go ahead and let's bring this down. And we can put this x on the inside. So now when you multiply x to the power of 1 times x to the power of n minus 1, we're just going to be left with x to the power of n, and why not? Let's put that 3 on the inside as well. Okay, that equals 0. So next up, what we want to do is make sure all our first terms have started x to the power of 1. What I mean by that is if you take a look at this one right here, when you plug in 2 for n, your x is just going to turn into a 1. So let's go ahead and sub out all these n's for 2's. So we're going to have a sub 2 times 2. Here 2 minus 1 is just going to be 1, and x to the power of 0 is just going to be 1. Then we just add the rest of the terms. Whoa. Not what I meant to do. Alright, so since these terms are what we get when we plug in 2 for n, we're going to need to start this at 3. Alright, this one is good as it is because when you plug in 1 for n, you're gonna start at x to the power of 1 already. So that gets to stay down. This one, however, we need to mess with a little bit. So let's bring down that negative sign and plug in 0 for all these n's. Alright, and then minus this. And just like the last one, this one needs to start at 1. Alright, now let me just grab this. I just want to move it over here. Alright, cool. So I can make some spaces real quick. All right, so next thing we need to do is make this equal 0. So we got, this starts at n equals 3. Subtract 3 from both sides and you're left with n minus 3 equals 0. So let's call this n minus 3. Let's call that k. So we're going to be able to start at k equals 0. However, since we changed, let me copy that space. Since we changed this to a k, we're going to need to change all these other n's to a k. So if k equals n minus 3, then k plus 3 is going to be equals to k. And then it's just going to be the same thing with these two right here. This one starts at n equals 1. We can set k equals to 0. And do k plus 1 equals to n. And this one can apply to both of these since they both start at n equals 1. Alright, so let's do that right now. Let's bring this down first. Oh no, wrong button. I meant to copy that. Okay, so it's going to be k equals 0. Wherever we see a k, wherever we see an n, we plug in a k plus 3. Alright, so it's going to be k plus 3 minus 1 or k plus 2. And this one right here is going to be k plus 3 minus 2 or k plus 1. Alright, awesome. Now we just got to do the same with these two. We just bring it all down at once. Okay, so k equals 0. This is going to be k plus 1. And k plus 1 here. Alright, last one. Alright, awesome. So now that we've done that, let me just rewrite this and then we can get to the fun part. So plus the sum of to infinity starting at k equals 0. Alright, so if you notice, we can pull out x to the power of k plus 1 out of all of these. So let's just put it up here. Alright, and then we can write the rest. So it's this. Dang it. It's going to go there. Plus this part right here. And minus this. Alright, so all that is going to give me 0. Alright, now after all that, we finally get to solve for what our question is asking us to solve for. So to start off, we know that this part right here is going to equal 0, right? So we can go ahead and bring that down. And just solve. Let me put one on the other side. So 2a sub 2. Oh, and you know what? I forgot to do that. Alright, so yeah, 2a plus 2 is going to be equals to 3a sub 0. Alright, now that we've done that, we were told that y of 0 equals 2. We can use this as our a sub 0, and we can actually use this as our a sub 1. So right off the bat, we're actually given 2 out of the 5 answers that we're asked for. Okay, so a sub 0 is going to be 2, meaning 2a sub 2 is going to be equals to 3 times 2, or 6, and a sub 2 is just going to give me 6 over 2, or 3. Okay, so let's type that in right there. Now, how do we solve for a sub 3 and a sub 4? That's where this comes in handy. Alright, so in order to solve for that, we can plug in 0 for k. So when you plug in 0 for k there, it's just going to give you 3. Here it's just going to give you 3. Here it's just going to give you 2. It's going to give you 1 right here. And I'm sure you can already see what the final steps need to be. So this is going to be 3 times 2 is going to be 6. 6a sub 3. And you know what? Let's move these to the other side. So 3. Damn. So 3a sub 1. What is that? A sub 1 is just 1, so we're just going to get 3 right here. Minus 1 times a sub 1, or 1. Okay. Once we do some subtracting and dividing, we're going to see that our next answer is going to be a sub 3 equals to 1 over 3. Alright, let's type that in. And finally, a sub 4. Same process as before. Let me copy this down. So to get a sub 4, here you just need to replace k with 1. So 1 plus 3 is going to give me 4. Same here. 1 plus 2 is going to give me 3. Here I'm going to get an a sub 2 times 2. And a sub 2 here. Okay, that equals 0. And then after that, it's just the same process as before. 4 times 3 is going to be 12. A sub 4 equals to a sub 2, which is 3. So 3 times 2 is going to give me 6, negative 6, plus 9. So a sub 4 is going to give me, this is going to give me a positive 3. 3 over 12 is 1/4. Alright, so let's type 1/4 into our little box here and check our answers. And there we go.